Hi there, this is Mrs. Meek, and once again we're going to continue our discussion of chemistry and biology. Today we're going to talk about water and why water is necessary for life. All right, so if we start looking at water's properties, all right, we're going to go back to something that we learned about a couple days ago when we talked about the idea that water forms covalent bonds. All right, water specifically forms polar covalent bonds. All right, and it is because of this that water is called a polar molecule. All right, what that means is that those electrons are being shared between the oxygen and the hydrogen, but they are unequally shared. The electrons tend to spend more time near the oxygen atom, therefore the oxygen atom will carry a slightly negative charge. The hydrogen atoms will tend to have a slightly positive charge. So water has two polar covalent bonds, all right, that create a charge on the molecule. It is because of this polarity that it allows water to be very well suited to help maintain homeostasis in organisms. All right, so let's take a look at water here. All right, so so here's your oxygen atom, here's your two hydrogen atoms. All right, because water is involved in these two polar covalent bonds, all right, the oxygen is slightly negatively charged, hydrogen's slightly positively charged. The positive charge on one water molecule will have a weak interaction with the negative charge on another neighboring water molecule. So water will form a matrix, all right, and it is because of these hydrogen bonds that allow it to have this weak interaction with other neighboring molecules that allow it to show properties such as adhesion and cohesion. If you've ever seen droplets of water going down a windshield, all right, it seems like they kind of stick together. That is because of this hydrogen bonding. All right, and here I have a picture of Michael Phelps in the most recent Olympics, and this picture makes him look really deformed, almost like he is being stretched, or he is being made to be more streamlined. And what you're actually seeing is these properties of water, that the water molecules want to stick together. They want to stick to the surface of the swimmer, and they tend to form this matrix right over top of the swimmer. All right, so that is both adhesion and cohesion. So both properties of water are being shown there. All right, water is also great for dissolving solutes in. All right, water can form homogeneous mixtures, and homogeneous mixtures are uniform throughout. All right, in a homogeneous mixture, you have a solvent, which is typically water, and a solute, which is what is being dissolved. So for example, if you're going to dissolve salt in water, the solute would be salt and the solvent would be water. All right, heterogeneous mixtures are mixtures that have distinct particles that settle out. All right, so suspensions are mixtures that certain particles will settle out over time. This salad here is an example of a heterogeneous mixture. All right, another heterogeneous mixture that you may be very familiar with is the concept of oil and water. Oil will not dissolve in water because water is polar and oil is nonpolar. All right, so because of water's polarity, it allows it to dissolve other molecules that are, or other compounds which are polar, but nonpolar molecules cannot be dissolved in water. All right, this also leads us to water's property as an acid and a base. So let's just review what acids and bases are. Acids are substances that release hydrogen ions when they're dissolved in water. All right, so the more hydrogen ions that are released, the more acidic the solution. Bases are substances that release hydroxide ions when they're dissolved in water, and the more hydroxide ions that are released, the more basic the solution is. All right, so oftentimes water is called a universal solvent. All right, so when we talk about acids and bases, all right, we almost always refer to what we call the pH scale. All right, so a pH scale is the measure of concentration of hydrogen atoms in a solution. And if the hydrogen atoms have a pH of 7, we consider that to be neutral, and that is exactly where water is. All right, so if you look at our pH scale, pure water, blood, tears all have pHs that fall in this neutral range. All right, if they have a pH value that is lower than 7, all right, those are what we call acidic. All right, so acidic solutions have pH values of less than 7, and right here we have battery acid at 0. Lemon juice, vinegar, which you've ever tasted, are pretty acidic, and they have a pH value of around 2. All right, and if you look at the other end of the pH scale, we look at the basic solutions have more OH ions, therefore they have higher pH values, things like baking soda, and all the way at the other end is sodium hydroxide. All right, so buffers are mixtures that can react with acids or bases to keep the pH within a particular range. In cells, we use buffers to keep the pH between 6.5 and 7.5. All right, we need a pretty neutral pH. All right, so what did we talk about having a neutral pH? Well, we talked about water. Water has a pH around 7. So this is also why we want to hydrate our bodies and have lots of water in our bodies. All right, it helps to flush our system. It helps to allow certain chemical reactions to occur, things to dissolve, but it also helps us to maintain the proper pH for our cells. All right, so I'm going to give you some information that'll help you determine whether something is acidic or basic. We're going to be doing a lab in the next day or two where you're going to determine the pH of common household substances, and you're going to need to try to make an educated guess to determine whether you think they're acidic or basic. So let's take a look at the two differences here at this table. Acids will turn litmus paper red, whereas bases turn litmus paper blue. All right, and litmus paper, which you may remember from your chemistry class or the part of chemistry that you took in integrated science, all right, litmus paper is what we use to determine pH. Acids typically taste sour, so if you've ever had Sour Patch Kids, if you've ever had any kind of sour candy, there's a good chance they've added citric acid, which is a natural occurring acid that has a very sour taste. Things that taste bitter are typically bases. Let's see, if they release hydrogen ions, then they're acids. If they release OH or hydroxide ions, they are considered bases. Acids have a pH less than 7, whereas bases have a pH greater than 7. All right, and why are we talking about acids and bases here in biology class? Well, acids and bases, even in very dilute amounts, can break down the protein molecules in cells. So it's really important, like we said, that we keep that pH between 6.5 and 7.5. There are actual situations in which people can undergo acidosis and die because their body becomes too acidic. All right, you also can burn your skin and experience actual skin burns with acids that are too strong or bases that are too strong. So for example, in your chemistry class, you've probably been introduced to hydrochloric acid. Hydrochloric acid has the ability to burn. All right, so does sodium hydroxide in a very pure form, which is a very basic a solution, but it also can burn your skin. All right, so your pH of your cells, the pH of your body must be maintained. Also, your body cannot carry oxygen if your pH is off. All right, so pH plays an important role, especially when we're talking about medical issues and when we start to see organisms that are not able to carry out homeostasis. It's typically a matter of pH and either being exposed to something or their body not maintaining proper homeostasis. All right, so we're going to watch a short video about the properties of water, and I will see you in a couple more days. Bye-bye.